Hello guys, welcome to Ramta Solutions. Welcome to your grade 12 physical sciences exam prep on optical phenomena and the properties of matter. Today's question paper is Physical Sciences Paper 1 of the Mpumalanga September 2023 examinations. Because this is an exam, it's important that we read instructions. Remember, all the instructions are important. All the instructions are important. However, we are going to read just a few. For example, that is instruction number 8. Show all formulas and substitutions in all calculations. That's very key. Instruction 9. Round off your final numerical answers to a minimum of 2 decimal places. So guys, in the middle of your calculations, if you happen to get decimals, just round them off to say 4 or 5 decimal places. Only the final numerical answer should be to 2 decimal places. Instruction 10, because this is not history, life sciences, or business studies, that is essay questions. Try to give brief motivations, discussions, and so on where required. So for this, a tip is if they say give a reason or reasons and it's 2 marks, or give 2 points or 2 reasons for each mark. Okay, just points. Instruction 11, you are advised to use the attached data sheet in case you forget formulas and in case you forget constants. Finally, we know that you are aiming for distinctions, but it's also important that your handwriting, the presentation of your work, is on point. Therefore, write neatly and legibly. Improve your handwriting, guys. Right, now let's get to the work. Normally, this topic is on question 10. Let's see what question it is on this paper. On this paper, it's not question 10, it's question 11. And by the way, we thank essay exam papers for their library of question papers. Oh, you said question 11, right? So let's see. This question is 13 marks. So 13 marks would mean 13 minutes, isn't it? Would mean 13 minutes. So we must spend 13 minutes on this. We must spend 13 minutes on this work. So let me try 75. I think it would be fine. Oh, 75. Okay, it says it's too much. Oh, and 75 is too much, guys. I will try 70. Okay, I'm zooming it to 70. Guess 70 is not bad. 70 is good. So let's see. Learners conduct an experiment to investigate the photoelectric effect. Metal disc M is irradiated with 3 light sources of different wavelengths, and the results obtained are noted in the table below. Okay, so we can see the light sources. So let's see. Light source A, photoelectrons are emitted and they move away from the metal plate. So this means here this wavelength is good, huh? Yeah. So let's see. Now let's see. Light source B, the wavelength is 620 nanometers. No photoelectrons are emitted. What does it mean? We don't know. We will see. So, and then this one here, 570 means, let's see, photoelectrons are emitted and do not move away from the metal plate. So this one here must be there. This one here must be the threshold wavelength, isn't it? It must be the threshold wavelength. Now let's see. Why? Because here kinetic energy is 0. So let's see. 11.1. Define the term work function in weight. It is the minimum amount of energy needed to eject electrons from a metal surface, isn't it? Minimum amount of energy. Let me use required. required, minimum amount of energy required to eject electrons from a metal surface. So even if you said minimum amount of energy needed to emit electrons from a metal surface, those are still okay, from a metal surface. All right, perfect. 11.2, explain why light source A releases photoelectrons from the metal disk. Here's a thing, guys, that you know. For there to be emission, when this frequency is less than the threshold, there will be no emission. Right? Okay, maybe I want to do this. There will be no emission. And if this frequency is greater than the threshold, there will be emission. Right? Now, something that I want you to see is this. Here, when the wavelength is smaller, do you see that? When the wavelength is smaller, so when the wavelength is smaller than 570, there are electrons emitted. So again, we can say when the wavelength is what? When the wavelength is, when the wavelength is smaller than, I'm gonna say threshold wavelength, then there will be, when the wavelength buddy. So here, when the wavelength is smaller than the threshold wavelength, there is emission. Alright, there is emission of electrons. So here, when the wavelength is greater than threshold wavelength, there is no emission. Right? There is no emission. Now, let's come back to the work. Remember, guys, we must spend 13 minutes on this. Coming back to the work. Explain why light source A releases photoelectrons from the metal disk but not B. This is because light source A has a smaller wavelength. Right? Has a smaller wavelength. If you're wondering, guys, remember wavelength is indirectly proportional to frequency. So don't be surprised. Okay? Now 11.3, calculate the work function of the metal M. With what I'm seeing here, at light source C, the wavelength here says, at this wavelength, it says photoelectrons are emitted but do not move away from the metal. They are not ejected. That means they have no kinetic energy. And since they have no kinetic energy, this is therefore the work function. And we are not given a frequency, so we will use speed of light over wavelength instead of frequency. Okay, we said Planck's constant is 6,63 times 10 to the negative 34. Speed of light is 3 times 10 to the 8, and the given wavelength is 570 nanometers. 570 times 10 to the negative 9 meters, right? Good. On our calculator, this is 3,49 times 10 to the negative 19 joules, isn't it? Now, let's go to the next one. Now, the next one says, the next one is asking us, right? The next one is asking us, let's see, to calculate the speed with which the photoelectrons are moving if disk M is irradiated with light source A. Okay, easy peasy, right? So let's just proceed. We'll just say, this one's 11.3.1. Okay, 11.3.1. So the next one is 11.3.3.2, 11.3.2. You know, energy is equal to work function plus maximum kinetic energy. So what is energy? So energy here will be Planck's constant, speed of light over wavelength. We did say Planck's constant is 6,63 times 10 to the negative 34. Speed of light is 3 times 10 to the 8. The given wavelength for light source A is 480 nanometers. Nano means 10 to the negative 9. So let's change and see what is what. So this energy is 4,4, why am I saying 4,4? 4,19, 4,14375 times 10 to the negative 19 joules. All right? Perfect. Now, we can therefore say energy of, maximum kinetic energy is equal to energy of the photon minus work function. Energy of the photon is 4,14375 times 10 to the negative 19 that we just calculated. And then the work function, we calculated it in 11.3.1. It was 3.49 times 10 to the negative 19, isn't it? 3.49 times 10 to the negative 19. Oops. So what do we get here? The answer that we're getting the kinetic energy to be 6,5375 times 10 to the negative 20 joules. But we know that half mass times speed squared is equal to kinetic energy. But because we are dealing with maximum kinetic energy, we will substitute it to be maximum speed. Remember, the maximum kinetic energy is of the electron. So we'll add the mass of electron. It is a constant that's given as 9,11 times 10 to the 9,11 times 10 to the negative 31. Okay. Now let's see. My calculator is still displaying 6,5375 times 10 to the negative 20. I will press divide, open bracket, 0,5, open bracket, 9,11 times 10 to the negative 31, close brackets. Now here we get V max square is 1,435,236 times 10 to the 11. Now, that value is still displaying on my calculator. I'll press the square root and then I'll press answer. I'm using Casio FX991ZA, okay? So it'll then be max is, what is it? This is 378,845,09 meters per second. If you like, you can also say it's 3, this is 300,000, so it'll be 3,79 times 10 to the 5 meters per second. If you like, you can represent it like this. Okay? This is our speed of light. Okay. Now, 11.4, if light source A is blue and light source B is orange light, which color of light is source C? Choose between violet, green, or red. So let's see. We know we have red, orange, yellow, green, blue, indigo, violet, and let's see, indigo, violet. We know that from indigo to red, this is an increasing wavelength, right? This is increasing wavelength. So we have orange here. They gave us the color. Orange was light source B, which is 620 nanometers. And then they said blue was A with 480. with 480 nanometers. Increasing wavelength, the other one that's not given is 570. It cannot be red because red is greater than 620. It cannot be violet because it's less than 480. Therefore, the only possible color is green. Okay, the only possible color is green. Okay, therefore that color is green. So we conclude by saying this light is green. Okay, so light C is green. Okay, light C is green light. Okay, that's it, guys. This is how you answer optical phenomena and the properties of matter exam questions. So see you next time, and bye bye.